All right, guys. Just wanted to get you caught up on what we did in class today. Today's Tuesday, October 19th. So if you're getting this, that means you're absent today. And we started this new lab. You can see here the acceleration due to gravity lab. Okay. So yesterday we talked about, okay, we know we can calculate the force of gravity between two objects, right? And we know if we know the mass of one object, the mass of the other object, and we know how far apart they are, we can calculate that force of gravity. So that tells us that mass has something to do with gravity. And we know that the more massive something is, like Earth, that exerts a really strong gravitational force. Okay, so if we had a planet that was more massive, say like Jupiter or Neptune, they're going to have higher amounts of gravity. Okay, less planets with less mass, like Mars, we can see that the force of gravity is less. Okay, so we know, okay, mass affects what force of gravity we have. Okay, so now what we want to look at is, does gravity or does mass affect how fast things fall? Okay, so with this acceleration due to gravity lab, what I first want you guys to do is you're going to do it in your notes just like we always do. Okay, so you're going to go through, you can see it says right here, purpose, hypothesis, materials, and data table in your notes. Okay, so basically what we're doing is we're going to take 3 tennis balls. Okay, we can see that here. Each one has a different mass, and I'll show you that in just a second. And we're going to drop them from the same height, and we're going to see which one hits the ground first. Now, some of you guys have already heard about this, you already know the answer. But then we're going to break down why here in the second part of the lab. Okay, so go ahead, pause the video. I want you to write in your purpose. I want you to write a hypothesis, basically saying, okay, which one of these balls is going to travel faster, right? Which one is going to accelerate faster and why? Okay, once you get that, I want you guys to add this data table in here. So basically what I did is I went in and filled in our results for the lab, what we should have seen. Okay, so go ahead and pause the video, fill that in now. Now, after we do that, we can calculate the average time. Okay, so you guys can take these numbers, right? And to do average, we just say simply 0.99 plus 1.01 plus 1.02, and then divided by 3, right? Because we had 3 trials. That's going to give us our average. Then it goes through the procedures. You can read through this if you want. This is just how we timed it, how we got the results we did. Okay, then when we get down here, it says complete the analysis and synthesis sections in your notebook. Okay, so it says analyzing your data. Enter your average times, okay, so whatever we get right here, into the Google Sheet provided. So on Google Classroom, you'll see you have a link to a Google Sheet, okay, and it should look like this. So now after you get your average times, this is the cool thing, right? We don't want to change anything in this acceleration column, and here's why. So you're going to enter in your masses, and then when you enter in your average time, say it's 1.01 seconds, whoo, look at that, okay? So it automatically calculates your acceleration for you, and then populates this data table, okay? So we can see now, it creates this nice little graph. We can see our different accelerations here, okay? And then when we get down to this part, we're just going to copy, basically we're going to write this in our notes, and we're just going to copy this data table down into our notes. Okay, so that's as far as we got today. For the analysis portion, if you want to jump ahead, it says which object had the greatest acceleration. So now when we look at this, you guys take things very, very literally, which is good sometimes, but really when we look at this, there's not much difference in acceleration. Object 3 didn't actually have less acceleration. That was probably human error, okay? So what we should see here is they pretty much had the exact same acceleration. So now we want to look at why. How did that happen? So we're going to use this F equals ma, so we got the mass of the tennis ball times the number we got for acceleration, to look at the force, to see if we can figure out, okay, why did that happen, okay? Now, this will say, was the force the same on all 3 objects? How do we know? Okay, that again, we should see that right here. Finally, when we jump down to this bottom portion, it says using terms force, mass, and acceleration, explain why Mars, and on Mars, an object only falls at 3 meters per second. Why is that acceleration less? What is different about Mars resulting in so much less acceleration? Okay, and then did you find mass did the mass affect the rate of the different objects? Okay, so did mass affect how quickly objects fell? Explain your answer, okay? If you have questions, send me an email. All right, bye-bye.